Respected team, greetings of the day. I am Mr. Karthik, working as Academic Head for Engineering and Senior Maths JEE Lecturer in Vijayawada, Andhra Pradesh. I am carrying an experience of 10 plus years. In these 10 years, I have trained more than 1000 plus students, and most of my students have got admitted in NITs and IITs. In this session, I am going to explain Rolle's theorem. Let me first try to explain it. Let f of x be any function in x subject to the following conditions. Let f of x be any function. Let f of x be any function in x subject to the following conditions. Subject to the following conditions. Number 1, f of x is continuous. F of x has to be continuous in closed a comma b. F of x should be continuous for all x belongs to closed a comma b. Number 2, f of x is derivable in open a comma b. F of x should be differentiable for all x belongs to open a comma b. Number 3, f of a is equals to f of b. First, so let f of x be any function in x subject to these three conditions. First condition is it should be continuous for all x belongs to closed a to b. It should be derivable in open a comma b, and f of a is equals to f of b. Then the most important thing is then there exists at least one point x is equals to c such that f dash c is equals to 0. And what is this c? Where c belongs to open a comma b. This is the beauty of Rolle's theorem, my dear friends. Rolle's theorem states that let f of x be any function subject to the following conditions. It has to be continuous in closed a to b. It has to be differentiable in open a to b, and f of a should be equals to f of b. Then there exists at least one point x is equals to c such that f dash c is equals to 0 for all c belongs to open a to b. For all c belongs to open a to b. I can explain this with a beautiful graph. Let's consider a function. Let's consider f of x be any function. Now, if we draw the graph of y is equals to f of x, let y is equals to f. Let this be the graph of y is equals to f of x. Let me consider a point x is equals to a here, x is equals to b, such that f of a is equals to f of b. And friends, it is so simple. If it is a continuous curve, and f of a is equals to f of b, definitely it has to take a particular turn. It has to take one turn, at least one turn has to be taken. Now there exists one point c, in between a comma b, such that f dash c is equals to 0. F dash c is equals to 0. At x is equals to c, if this is the curve y is equals to f of x, then f dash c will be equals to 0. That means the geometrical interpretation of Rolle's theorem states that for any curve y is equals to f of b, for any curve y is equals to f of x, there exists a point c in between 2 points a comma b. In between 2 points a comma b, where f of a is equals to f of b, such that f dash c is equals to 0. That means a tangent will be, there exists a tangent, at least one tangent in between a to b, such that that tangent is going to be parallel to x-axis. The slope of the tangent is going to be 0. there exists one tangent in between the points A to B such that f of A is equals to f of B, and that tangent is going to be parallel to x-axis, and this is what the geometrical interpretation of Rolle's theorem. And why did we say at least one? We are not restricted to one, we are saying at least one. I said there exists at least one point x is equals to c. Now if you understand the same, I'll draw one more graph. Let y is equals to f of x be any other curve. Let y is equals to f of x be some other curve. Now I am taking 2 points such that this is x is equals to a, somewhere here again x is equals to b. See, now this is our curve y is equals to f of x. It is continuous from closed A to B, it is differentiable from open A to B. Now f of A is equals to f of B. Now you see how many tangents which lie in between A comma B such that all these tangents are parallel to x-axis, So that's the reason we said in the definition there exists at least minimum 1 point we get. If f of A is equals to f of B, then there exists at least 1 point x is equals to c such that f dash c is equals to 0. This is what the geometrical interpretation of Rolle's theorem. Geometrical interpretation of Rolle's theorem states that for any curve y is equals to f of x, there exists a point in between 2 points A comma B where f of A is equals to f of B, then the tangent at C will be parallel to x-axis. I said at least one tangent, Let's do understand some more note points. Let's understand some note points. First note point that we can take is the converse of Rolle's theorem is not true. The converse of Rolle's theorem need not to be true. Converse of Rolle's theorem need not to be true. Converse of Rolle's theorem may or may not be true. Converse of Rolle's theorem may or may not be true. Next, most important point. Coming to JEE, if there exists, like if we come across a question involving the roots of differential, then most of the cases they are giving an idea that we are supposed to use Rolle's theorem. And what is this? Now let f of x be any differentiable function. Let f of x be a differentiable function. Let f of x be a differentiable function, and f of x is equals to 0, and f of x is equals to has two roots. F of x is equals to 0 has two roots. Then there exists at least one root. Then there exists at least one root. Then there exists at least one root for and one root such that f dash c is equals to 0. Such that f dash x is equals to 0. I mean to say that, my dear friends, even this is also the application of Rolle's theorem. If I draw a curve y is equals to f of x, see, if I draw a curve y is equals to f of x, now these two alpha comma beta are the roots of y is equals to f of x, are the roots of f of x is equals to 0. These two alpha and beta are the roots of f of x is equals to 0. Now if we have two roots, then there exists at least one, I said, at least one root of f dash x such that f dash c is equals to 0. And one more most important point is, for any point number 3, if f of x is equals to 0 has exactly n roots, n roots, has exactly n roots, then f dash x is equals to 0 has at least n minus 1 roots. Most important point. If f of x is equals to 0, first thing, it has to be a differentiable. If f of x is equals to 0 has exactly n roots, as n roots for all x belongs to closed a comma b. If f of x is equals to 0 has exactly n roots in x belongs to closed a to b, then f dash x is equals to 0 will be having at least n minus 1 roots. We'll take a beautiful graph and I'll try to explain. Suppose do understand the case here. Now f of x is equals to 0 has alpha, beta, gamma, delta, 4 roots. Our f of x is equals to 0 has 4 roots. Now how many roots of f dash x do we have? How many roots of f dash x do we have? 1, 2, 3. So if f of x is equals to 0 has 4 roots, then f dash x is equals to 0 will be having at least 4 minus 1 roots. Why did I say at least? I'll consider one more graph. See, my dear friends. Now, this equation has roots alpha, beta, gamma, delta. F of x is equals to 0 has 4 roots alpha, beta, gamma, delta. Now, how many roots do we have for f dash x is equals to 0? 1, 2, 3, 4, 5, 6, 7. We will be having 7 roots. So that's the reason I said if f of x is equals to 0, if f of x is differentiable in open a to b and has exactly n roots in this interval, then f dash x equals to 0 will be having at least n minus 1 roots. This is the beauty of Rolle's theorem. Whenever we come across in questions, whenever we come across the differentiable roots, the roots of the differentiable or roots of f of x is equals to 0, make sure that we are going to use Rolle's theorem. So this is the theory regarding Rolle's theorem. I would like to recap the definition of it. Let f of x be any function in x subject to the following conditions. It has to be continuous in closed a comma b, it has to be differentiable in open a to b, and f of a is equals to f of b. Then there exists at least one point x is equals to c such that f dash c is equals to 0 for all c belongs to, c has to lie in between a to b, c has to lie in between a and b. So this is regarding the beauty of Rolle's theorem. Now we'll step into problems. The first problem which we have is if capital AI is equals to xi minus ai divided by mod of xi minus ai, where I takes from 1 to n and a1 less than a2 less than an, then limit extends to am, a1 capital A1 into capital A2 into and so on till capital AM, where 1 less than or equals to m less than or equals to n is equals to 4 options do we have. So friends, they clearly said 1 less than or equals to m less than or equals to m. So definitely A1 will be less than or equals to, A2 will be less than or equals to, A1 is less than, A2 less than, A3 less than, A4 and so on. Somewhere we will be having AM also and so on. At end we have as m less than n, they have given m less than n. So this can be the arrangement, this can be the order of a1 to an, small a1 to small an. Now I am going to take two beautiful cases. First case, if our x, because in our limit we have modulus. First we have to come out of that particular modulus. To come out of that particular modulus, we have to check the sign of x minus ai. First, as x tends to am, first if x lies in the left neighborhood, if x lies in the left neighborhood of am, then what happens, friends? Suppose now x lies here, x lies in the left neighborhood of x lies in the left neighborhood of am, then what happens now? X minus ai will be negative 1. X minus ai will be negative 1. X minus ai will be negative. I mean to say mod of x minus a. I mean to say ai is now ai will be equals to here we have x minus ai divided by mod of x minus ai. Now this x minus ai will be negative for I equals to m. Yeah, because x lies in the left neighborhood of am. So x minus am will be negative. Am plus 1 negative, x minus am plus 1 negative, and so on. X minus an will be having negative. So for I is equals to m to n, for I belongs to m plus 1 to n, will be having this as negative. When this is negative, positive by negative same, we get ai will be negative 1. So I mean to say ai will be negative 1, capital AI is negative 1 for all, for I is equals to m plus 1 and so on till n, and plus 1 for all. Suppose from 1 to m minus 1 you take, see, x minus a1, x lies somewhere here, x is positive now, x lies in the left neighborhood of am, so x minus ai, definitely a1 is am, when x lies in this particular, definitely x value will be greater than a1. So x minus a1 will be positive, x minus a2 will be positive, same by positive, you get plus 1. So this is for I is equals to 1, 2, 3, 4 and so on till m minus 1. And so on till m minus 1. Now other case I take, friends, case 2. Number 2, if x lies in the right neighborhood of am, then what happens, you see? Friends, imagine here is our xi now. Here is our x. In previous case, here we, now x is in the right neighborhood of am. When it is right neighborhood of am, what is x minus am? X will be greater than am now. X minus am will be positive. But x minus am plus 1 is negative. So from m plus 1 to an, from m plus 1 to n, x minus ai will be negative. That means I can say clearly ai is equals to negative 1 for all I is equals to starts from m plus 1, m plus 2 and so on till you get n, and positive 1 for all I is equals to 1, 2, 3 and so on till m. I hope you have understood. When x lies, we have taken only two cases, when x lies in the neighborhood, left neighborhood and right neighborhood. Now my dear friends, do understand the beauty of this. Limit x tends to am. I have to split it into two cases because we have, when we have taken x neighbor in the left neighborhood of am and right neighborhood of am. So I would like to take limit x tends to am minus. First I am finding left hand limit LHL. Let me find LHL. A1 into A2 and so on into AM and so on into AN. Now guys, what happens? If you understand, when x tends to AM minus, if you understand, from A1 to AM minus 1, from A1, A2, A3 and so on, you will be getting plus 1. And AM plus 1 and so on, you will be till AN, all are negative 1. So this is nothing but, then this is equals to limit x tends to, so this is nothing but from AM to AN, from AM to AN, you get negative. How many terms we will be having from AM to AN? N minus M plus 1. how many terms will be having from m to n? N minus m plus 1. So simple, guys. Suppose if you have 1 2 3 4 5 terms. Now if you wish to check total number of terms, last minus first, 5 minus 1, add 1 to that, that's it. Now n minus m plus 1. So here you get simply this particular limit value is going to be minus 1 whole raised to n minus m plus 1. That's it. I hope you have understood. Next, if I find RHL, right hand limit extends to am plus a1 into a2 into and so on. We have am somewhere here and so on till an. This will be equals to in the right, when x lies in the right RHL, if you see, it is extends to am plus, fine. From a1 to a2 and so on till am minus 1 you get, and so till am you get plus 1. From a1, a2, a3 and so on till am you get plus 1. Okay. Now from am plus 1, am plus 2 and so on till n you get negative 1. So how many minus ones do we get? Last minus first, add 1 to this. So n minus m minus 1 plus 1. Then you get this is nothing but minus 1 whole raised to n minus m. Now friends, this is LHL. LHL is finite, RHL is finite, but these two are not equal. I mean, these two are not equal. LHL not equals to RHL. Hence, limit extends to am, a1 into a2 and so on an does not exist. Our answer will be option D, does not exist. Hope it is clear. Good, great. Next. Second question. ABC is an isosceles triangle inscribed in a circle of radius r. If AB is equals to AC and H is the altitude from A to BC, then the triangle ABC has perimeter so and so, area. Then limit H tends to 0, capital A divided by P cube they are asking. So simple, friends. So simple. First let's draw a circle. Let's draw a circle. Let's draw a circle. Let's draw a triangle also. Isosceles triangle. Let's draw an isosceles triangle. Let's draw an isosceles triangle. Yes, let this be our triangle. Okay, consider triangle ABC. Let ABC be the triangle. Circle with the center O. AB is equals to AC. Friends, we know the most simplest thing. If in a triangle ABC, if AB is equals to AC, the median drawn through vertex A will also be the altitude. And don't know, no matter what it is, it will be always passing through the center. So let this be my altitude as well as this will be my altitude as well as here AD will be my altitude as well as median. If this is median, definitely BD will be equals to DC. BD is going to be equals to DC. Now OB becomes the radius of this particular circle. OB becomes the radius of this circle. They have given altitude of this triangle is small h. Altitude of this triangle is going to be small h. Okay, altitude, and from OA it's anyhow r. Now by using Pythagoras theorem in triangle OBD, let's use Pythagoras theorem. By Pythagoras theorem, what can we say? OB square will be equals to BD square plus OD square. So clearly I can write OB square is nothing but R square. So R square is equals to BD square, and I don't know, plus OD square. How can you get OD? Because AD is completely H. AD equals to H. They have given AD is equals to H. And OA is equals to R. So OD will be equals to H minus R plus H minus R whole square. So from here, BD square I can write it as R square minus H minus R whole square, which implies BD square will be equals to A square minus B square, A plus B into A minus B. That becomes H times 2R minus H. Therefore, finally, BD will be equals to square root of H of 2R minus H. Let this be aside. Now, how do we get the area of triangle? Half into base into height. Anyhow, we know base now. If BD we know, we get BC, twice BD. And H is already. So, from here, from this particular thing, I can get capital A, that is area is equals to half into base is twice BD. So 2 times of H times 2R minus H. 2 times of root of H times 2R minus H into height is again H. So 2 gets cancelled. Capital A will be now H times square root of 2R minus H. Okay. Capital A will be equals to H times square root of H of 2R minus H. Now we know capital A. They have already given capital P. Now they are asking limit H tends to 0. Limit H tends to 0. Limit H tends to 0. Capital A divided by P cube. Capital A divided by P cube we need. Chalo, let's find it. Let's find it. Limit H tends to 0. Capital A divided by P cube, which is equals to limit H tends to 0. What is capital A? H times square root of 2R minus H. H of square root of 2R minus H whole divided by, what is P guys? P is 2 of 2HR minus H square. 2 of 2 root 2HR minus H square. 2HR minus H square plus root 2HR. Everything is being cubed. Now this is what they are asking. Suppose, imagine friends, if you are going to substitute H is equals to 0. Apply limit. 0 times something, numerator will be 0, denominator will be 0. So you get, numerator will be 0, denominator. You get 0 by 0 form, indeterminate form. So you are not supposed to take that. Now let's do something here. Limit H tends to 0. Limit H tends to 0. I try to take even H out here. Then I get H times root H of 2R minus H. Okay, that's fine. 2 cube will be 8. 2 cube will be 8. Now inside I try to bring H out. Root H out. So I get root H times, if I get H out, 2, I'll do something here which makes so simple. H common, 2R minus H plus H of 2R whole raised to power 3. That becomes limit H tends to 0. H times root H will be nothing but H power 3 by 2 of square root of 2R minus H whole divided by, if I take root H out, 8 times of root H will nothing but H power 1 by 2 of 2R minus H plus 2R whole raised to power 3. So that becomes limit H tends to 0, H raised to 3 by 2 of square root of 2R minus H divided by 8 times H power 1 by 2 whole raised to 3. We get H raised to 3 by 2 times 2R minus H plus root 2R. then you h power 3 by 2, h power 3 by 2 gets cancelled. Now if you are going to substitute h is equals to 0, no matter what, we are not going to get an indeterminate form, we will be getting a finite value. Let's substitute. So 2r minus h, so we get numerator will be 2r whole divided by 8 times 2r plus, it is whole raised to 3 here, 2r plus root 2r plus root 2r, 2 times root 2r, we get 2 times root 2r, 2 times root 2r whole raised to 3. Now that becomes, guys, 2r divided by 8 times 2 cube is again 8 into root 2r whole cube will be 2r times root 2r. So root 2r gets cancelled. Finally this will be 8 8 is 64 times 2r, which is equals to 1 by 128 times r. Clearly we get? Yes, option C is our correct answer. So simple, guys. First we have considered a triangle, isosceles triangle. So median will be altitude, median. Now BD, we found BD. Why did we find BD? Because to get the area, we found BD just by using simple Pythagoras theorem. From there, we just substituted. We found area and we just substituted everything in this. Clear? The final answer is 1 by 128 times r. Next question. The number of integral solutions of the equation x1 times x2 times x3 and so on, like into x4 is equals to 210. Guys, given an equation x1 into x2 into x3 into x4 is equals to 210. The most easiest thing that we know, we can prime factorize 210 as 210 can be prime factorized as 2 into 3 into 5, 5 2 is 10, 10 3 is 30 into 7. So 2 into 3 into 5 into 7. Yeah. Now we have 4 prime factors for 210. The prime factorization of 210 is 2 into 3 into 5 into 7. We have 4 prime factors. The most simple thing, friends, most simple thing. Now these 4 prime factors has to be distributed among 4 boxes, like 4 variables, among 4 variables. How many we get? 4 into 4 into 4 into 4. We get 4 raised to 4. These 4 prime factors 2, 3, 5, 7 has to be distributed among 4 variables. Then we get 4 raised to 4. Okay. But the thing is here, they are asking number of integral solutions. But all of these are only positive solutions we got. Till now we got only positive solutions. How do we get negative solutions? So just suppose x1 into x2 into x3 into x4 is equals to 210. 210 means positive 210. When do we get the product as positive? Case 1, 2 negative, 2 negative, 2 positive. Case 2, 4 negative, 0 positive. None, 4 negative, all 4 negative, or all 4 positive. Now when you consider, like, we have to get negative solutions also. In this case, out of 4, 2 has to be negative. So like among 4, 4c2 into 2, again 2 positive, the leftover 2, 2c2. I hope you understood. First we will be selecting any 2 out of 4. We assign negative signs to them. So 4c2 into 2c2. Then we get 4c2 is nothing but 6, 2c2 is 1. We select all the 4 of those 4 are all are negative. Then we get 4c4, which is equals to 1. Here none of them is going to be negative. If all the 4 are positive, none of them is going to be negative. Then we get 4c0, which is nothing but 1 again. Now how many number of non-negatives, negative solutions do we get? 6 plus 1 plus 1, which is equals to 8. Now these 8 non-negative, this 8 negative solutions has to be associated with 4 raised to 4. Therefore, total number of, finally we can say clearly that total number of integral solutions, is equals to these 8 negative solutions has to be associated with 4 raised to 4. We get by multiplication theorem 8 into 4 power 4. Answer option C. So simple. First we found all, if we are going to distribute all these 4 prime factors among 4 variables, we will be getting only positive solutions. But they are asking all integral solutions. Integral solutions mean it can be positive, it can be negative. Coming to, how did you find negative? The product is going to be positive in only these 3 cases. 2 negative, 2 positive, 4 negative and 4 positive. These 3 cases we found, and these 3 cases has to be associated with 4 power 4. By using multiplication theorem, the final total number of integral solutions will be getting as 8 into 4 raised to 4. So I hope you have understood this session clearly. Thank you all. Take care.